Okay, so one other way that indicial equations can be solved is first expressing them in a quadratic form and then solving them using null factor law, which we've all used before. So this works best when you've got equations that have index form similar to a is to the power of 2x and ax appearing in different terms. So just like we have x squared and x terms in a quadratic equation, similar here. So let's have a look at this example. So solve for x if 5 to the power of 2x minus 4 times 5 to the power of x minus 5 equals 0. So the first thing we need to do is to rewrite that first term so that we can start expressing things in our quadratic form. So 5 to the power of 2x minus, I'm just rewriting the equation first, 5 to the power of x minus 5 equals 0. So that first one we're going to write as 5 to the power of x. We're going to split up our power. 5 to the power of x, and is really annoying. 5 to the power of x, all squared, and the rest of it's actually going to stay the same. Minus 5 equals 0. So you can see now we've actually got a squared term, 1 to the power of 1, and one that's just got a constant. So you're going to rewrite indices so we have a squared term. So once we've got it in that form, we can actually start solving into a more simpler form. So rather than having 5 to the power of x, which is really messy, let's substitute another variable for that and let's define that. So let's say let y equal 5 to the power of x, and we're going to substitute this in. Really annoying pen. Substitute. Sorry, this is so awkward. Substitute. So we can write more clearly in quadratic form. Okay, so let's just do that. So that's going to, instead of writing 5 to the power of x all squared, we're going to write y squared minus 4y minus 5 equals 0. I'm going to factorize in the normal way. So we're looking for terms that, of course, multiply to give us negative 5 and add to give us negative 4, and that is going to be negative 5 and 1, positive 1, and then factorize in the normal way, y minus 5 plus 1, y minus 5, making sure our terms in our brackets are the same, our expressions rather in our brackets are the same. Collect our brackets. Y minus 5, y plus 1 equals 0. Now we can solve this using the null factor law. I'm just going to insert some more space. So we're definitely going to need that. Okay, so by null factor law, that tells us that we can split our factorized terms to have two expressions. So either y minus 5 equals 0 or y plus 1 equals 0. So solve for y, we have y equals 5 or y equals negative 1. Now, in this case, our answer has to be positive because 5 to the power of x equals 1 has no solution. So in this case, we're going to actually reject our y equals negative 1 answer because our answer must be positive. So just like you might reject a negative answer if you're working with length, same situation here. And that is because 5 to the power of x equals minus 1 has no solution. So that's not possible to be part of our solution here. So we need to think about that at this point. So we're going to find out if y equals 5, what does that give us to look like if we substitute it back in? So if we say instead of this time y equals 5x, so y equals 5x is what we're substituting back in, which is, remember, what we defined up above when we substituted it. Y equals 5x, but we now know y is 5, so we can say 5 equals 5x. We need to rewrite 5 as 5 to the power of something. So that means 5 to the power of 1 equals 5x, and we can equate our indices just like we did before. So therefore x equals 1. Now it's always best at this point to substitute back in our answer and just check that we're right. So let's do a check, and this is part of your justification anyway. So to do that, we're going to sub x equals 1 into the initial equation, the initial one, the one you started with. So that will look like, and let's just do the left-hand side, because then we can see if we end up with 0, it's going to equal the right-hand side. So let's see if it makes that equation true. So 5 to the power of 2x minus 4 to the power of 5x minus 5 is the left-hand side of our initial equation. So let's substitute x equals 1 instead. So 5 to the power of 2 to the 1 minus 4 times 5 to the 1 minus 5 is going to equal 25 minus 20 minus 5, which does equal 0, which equals our right-hand side. So it must be correct. So we should be able to say here, therefore, as the solution satisfies the initial equation, the result is justified. Okay, so I want you to have a go at this one yourself. The results you're looking for are y equals 8 and y equals 4, but you need to show full working, so that's what you need to do here. Y equals 4, and get down to that, and also do the justification and the checking of your solutions. So that's one way we could do it. I just want to have a look at one more example that's a little bit different. So we've got solve 2 times n to the power of x minus 4, 3 to the power of x minus 6 equals 0. So there's a few actual ways you could do this. So we could divide the entire equation by 2 before we even get started to simplify it, but I'm not going to do that now, but you could definitely do this at this point. Now I'm just going to write the equation first. And currently we have bases that are not the same, so that's where we're actually going to start here. We need to get bases that are the same. So of course we could rewrite 9 as 3 squared x, and then we've got 3x, and 6 doesn't matter, it's just a constant anyway. So now that we've got it written in this format, we need to rewrite it so that we've got a squared term, so that we can work with our null factor law and we end up with quadratic format. So once it's like that, we should substitute in another value, which is going to make it a bit easier to solve. So again, I'm going to choose y, let y equal 3 to the power of x this time. So if we substitute that in, we're going to end up with 2 y squared minus 4y minus 6 equals 0. So you could see you could actually divide the entire equation by 2 at this point to simplify, but I'm not going to bother do that. I'm just going to factorize as normal. So we're looking for factors that multiply to give us negative 12 and add to give us negative 4, and they are of course negative 6 and positive 2. So let's just factorize as normal. 6y plus 2y minus 6 equals 0. So 2y is going to become our common factor. And collect the terms outside of the brackets. Remember, it doesn't matter which one you write first because we're multiplying, and you end up in the same answer. So now I'm going to solve using null factor law. Again, I'm going to need a bit more space. So by null factor law, y minus 3 equals 0, or 2y plus 2 equals 0. So y equals 3, or -1. So we're going to reject our negative answer. Now, if you had already divided by 2 earlier in the process, you would see that you would end up in exactly the same place here and with the same answers. So it makes no difference if you do that or if you don't. Sometimes it just makes it easier to solve the equation, but it's up to you in most cases. So 3x equals 3 here. That, of course, means 3 to the power of 1. So x equals 1. And that's our answer. Let's check. Check. We're going to sum x equals 1 into the initial equation. So the left-hand side of that equation will look like 2 to the power of 9x. So notice it's not one that has anything done to it. It's literally the initial equation. So 2 times 9 to the power of 1 minus 4 times 3 to the power of 1 minus 6 equals 18 minus 12 minus 6 equals 0, equals our right-hand side. Therefore, so annoying, as the solution satisfies the initial equation, the result is justified. So you should now have a go at more questions, making sure you're very clear what needs to happen in this case. Good luck.